Hello students, in this video we'll see more examples of making u-substitutions. Here's the first example we'll look at. Let's find the integral of sine of x plus cosine of x divided by the square root of sine of x, cosine of x, minus sine of x dx. Again, this looks a little bit messy. However, we can make the following observation. We can observe that if we let u be cosine of x minus sine of x, then the derivative of this function, then du, is the same thing as negative sine of x minus cosine of x dx, which is the same thing as negative sine of x plus cosine of x dx, or equivalently, negative du is equal to sine of x plus cosine of x dx. So this entire numerator over here in this integral is exactly just the same thing as negative du. So when we make this u-substitution, our integral turns into negative du over the square root, and now I have a cosine minus sine. That's exactly just u. So let's write this in power form. This is negative u to the negative 1/2 du. Integrate this. This is negative u to the 1/2 divided by 1/2 plus a constant c. Therefore, what this is, our antiderivative is exactly just going to be negative 2 u to the positive 1/2 plus c. Now we replace what u is. So this is negative 2, the square root of cosine x minus sine x plus c. And there's a solution to our problem. Let's take a look at another example, example number 2. Let's find the integral of x times x minus 2 to the 1/3 power dx. A little bit trickier problem. What we want to do is we want to take this x minus 2 and remove it from this cube root because that's a little bit of a mess. So what we'll do with this problem is we'll let u be x minus 2. Then that's the same thing as saying that x is equal to u plus 2. And du is just the same as dx. So there's no difference between du and dx. However, when we change this integral into u's, we're going to have the integral. Let's replace x with what it is. X, this x over here, will be replaced with u plus 2. So I'll have a u plus 2. Then this x minus 2 is exactly just u to the 1/3, and then dx is the same as du. Now we can expand this out. This will be u to the 4/3 plus 2 u to the 1/3 du. Now we use the power rule. So this will be u. I'm going to raise this power to 7/3, divide by 7/3, plus raise this power to 4/3, so 2 u to the 4/3 over 4/3 plus c. Now we can simplify this a little bit. This is going to be 3 over 7 u to the 7 over 3. And then we're going to have a 6 over 4, and 6 over 4 is the same as 3 over 2, so plus 3 over 2 plus 3 over 2 u to the 4/3 plus c. And the last step is to replace u with what it is. So this will be equal to 3 over 7. And then I have a x minus 2 to the 7/3 plus 2/3, 3/2 rather, plus 3/2, and then x minus 2 to the power 4/3 plus c. So here was an example where the differential du and dx were no different. However, the key itself, the u-substitution itself, was able to take the integral and transform it into a more elementary integral. Thank you very much.